Given the function f of x equals 2x to the fifth minus 5x to the fourth plus 10x cubed, find the x coordinates of the inflection points. Inflection points exist when f double prime, or the second derivative of x, equals 0. So we need to take the first derivative and take the second derivative, set it equal to 0, probably do some factoring, and then take it from there. So f prime of x, the first derivative is going to be power rule, so that's going to be 10x to the fourth minus power rule again, 20x to the third, plus power rule again, 30x squared. Now let's take the second derivative. F double prime of x is going to equal power rule 40x cubed, power rule minus 60x squared, power rule plus 60x. Now let's factor what we can factor. F double prime of x, I can factor out a 20, I can factor out an x, and that leaves me with 2x squared minus 3x plus 3. Now this is fun, because here we have an obvious point at x equals 0. Try to factor that out. You can't. See, if I set this equal to 0, which I forgot to do, so 20x 2x to the second power minus 3x plus 3. If you do the zero product property, yeah, you get that x equals 0. You can't factor that out. That's not factorable. So I'm going to bring back an old friend called the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a, singing a song. You're my A, you're my B, you're my C. So x is going to equal negative 3 plus or minus the square root of negative 3 squared minus 4 times 2 times 3 all over 2 times a, which is 2 times 2. Now, let's write that out. X equals positive 3 plus or minus the square root of 9 minus 8 times 3 is 24. Now, that is a problem, because you're going to get the square root of a negative number. These are imaginary. Oh, no. So if these are imaginary, you only have one inflection point, because these are not real numbers. So my one and only inflection point is x equals 0. After all of that, lame city. But that's how you do it.